Science,
engineering,
medicine, chemistry,
physics,
biology, humanities, cardiology,
computing,
public health, global
aeronautics, science communication.
Hello again, everyone. I'm Gareth Mitchell. I hope you're well. Welcome to our October edition, where we'll be uncovering the inner secrets of the Large Hadron Collider at CERN. And also, if you're a medic, does that make you a scientist? A medical student grapples with just that question. And I learn something new every time I do this podcast, and this time it's that there are bees in the Arctic. Not many, which is why the BBC has been calling on an Imperial researcher to help with the Frozen Planet 2 series.
The BBC crew were very, very interested in trying to understand how these bees cope to such cold conditions. But they really wanted to get behind the story of how a single queen that hibernates over winter has to forage around over these very sort of snowy, very cold conditions and then start her own colony.
The Imperial College Podcast.
All right, well, let's jump in. As we always do, we're going to start with some news around the college, and Maxine Myers joins us. Maxine, really great to see you as ever. And, well, it's exciting times, isn't it, over at the Biomedical Research Centre? Tell me more.
Yes, it is exciting times. So the Biomedical Research Centre has received just over £95 million from the National Institute for Health and Care Research. And this is to help for the next 5 years develop new treatments, medical technologies and diagnostics that can benefit the communities locally and internationally. The Biomedical Research Centre is a partnership between Imperial and Imperial College Healthcare NHS Trust. This new funding will also allow them to do research into new areas, so pregnancy and prematurity as well. And it's a £5.3 million increase on the last award in 2016. So really exciting, really great opportunities to develop the work that they've been doing over the last 5 years and to go into new areas of research and healthcare needs.
Great to have an increase in funding, especially what's going on in the current climate as well. So, Maxine, there are 4 common threads, aren't there?
Yes, there are. So the 4 common threads will be looking at early diagnosis, so developing new tests or improving current testing so we can speed up diagnosis and allow for earlier treatment. Precision medicine, so this is about tailoring treatment to a patient's specific needs, and that helps to improve their outcomes. We're also looking at digital health, so using computer technology, so to provide doctors with more accurate information for better treatment, and also to allow patients to be more empowered to manage their health. And then something called convergent science. So this is bringing different scientific fields together to look at and provide new perspectives and solve really complex health research challenges.
And there's also going to be an increasing focus on EDI, isn't there, as this new funding takes place?
Yeah, so the Imperial Biomedical Research Centre has a new EDI framework, and this is to ensure research studies really fully reflect the communities and the staff it will support. So, for example, under this new framework, staff across Imperial College London and Imperial College Healthcare NHS Trust, they'll have improved equality and equity to research opportunities, and also specific developments, including establishing links to networks for Black healthcare professionals, and making sure that there's better equity of access to research trial and providing support for female academics and training for those who are not doctors so they can do research as well. So nurses, midwives, pharmacists, for example.
So there we are. That's a funding increase at the Biomedical Research Centre. Maxine Myers, thank you very much indeed for that. Now, as autumn well and truly sets in and the nights draw in, then I think we all need a little bit to fill our diaries and to keep us all excited and engaged. And what better than to go to one of our Lates events? There's plenty going on over the autumn, as we're about to hear from James Ramiro. So what do we need to know about the Lates series itself, for those who may not have encountered it so far, and indeed what we're going to see specifically in the coming months?
Yeah. So the Imperial Lates they're an after work sort of evening celebrations of some of the science that we do here at the college. So they take place in South Kensington, our college main entrance, which sort of opens out onto Exhibition Road, so really easy to find. We fill that space with academic teams, researching teams they're running live experiments, doing demonstrations, they're giving talks. We pair some of them with artists and they create art pieces, or they run sort of craft workshops where you can make something inspired by science. So it's a free evening. It runs for 3 hours. You can drop in whenever you want. There's a bar, there's a DJ. So it's quite a sociable, fun way to sort of find out all about the science that we do here at Imperial.
And looking ahead then, the next one I believe is in November, and the theme is very tiny science. So it makes me wonder if you're going to hold the whole thing in a matchbox. But I'm only being silly. Tell me what's really happening.
No, yeah, so with each late, we sort of choose topics or themes that sort of allow us to bring different parts of the college together, and sort of it allows you to explore different areas of science, and we sort of have a bit of fun with it as well. So tiny science, or the science of the very small, is one of those topics. It allows us to bring together researchers working on sort of nanotechnology, atomic physics, material science, microplastics. We're going to have talks about the future of the Large Hadron Collider, opportunities to make artwork inspired by black holes, to search for those phenomena, cosmological phenomena. So it's an evening celebration of the very small. We're going to try and bring it to the scale that people can enjoy it, feel part of it.
And what about December? Do you have anything in the diary yet for December?
Yeah, so there's a full programme we've sort of confirmed. So there'll be 4 lates running across the autumn and spring term. So in December, it's called Heads Up. So it's the science of everything that's above our heads, really. So there's a bit of astronomy there. There'll be a bit of meteorology, weather systems. We'll have some drones. We'll be looking at sort of the future of aviation and whether we can fly conscience-free from a green perspective. So lots of opportunities to think about all the things that fly around above our heads or exist above our heads, and have a bit of fun with that.
Right, and what about the new year? Have you launched those yet then?
Yeah, no, we can announce them. I can definitely talk about them, yeah. So February, we're looking at drugs. But that's both sort of drug development and sort of drugs for various medical attributions, but also the use of things like psychedelics in treating depression, our research into addiction and rehabilitation and things like that. So, and we might also have a little bit of fun with topics around coffee and whether love is a drug and things like that. So lots of different ways of approaching that subject. And then the 4th Lates, which will be in March, it's a slightly different theme in a sense. That it's not a research-inspired theme. It's how we're going to explore our science. So it's called Play, and we're going to sort of challenge our academics and research teams and students to think of ways that they can use board games, computer games, play, all different playful concepts to sort of convey and engage our audiences with the research that we do here at the college.
As for the November one, coming back to that then, that's on November the 10th, isn't it? Starting at 6 o'clock, so running from 6 till 9. What else do people need to know, and especially if they want to come along?
If you search in sort of Imperial Lates in Google, you can go to you'll find the page, and then there's a link there where you can register. So we'd encourage anyone to register in advance. You'll receive the programme. It allows you to submit some questions for some of the big panel discussions on topics like microplastics. So yeah, sign up there, and then we'll send you all the details of what you need to do to attend. But yeah, it's a free event, so you don't have to worry about any payments.
We like free. Especially in times like these. James, thank you very much indeed. Very much looking forward to that series, and of course plenty more details via the Be Inspired pages on the Imperial website. So I hope I've tempted you to come along, but you don't have to wait until then before you peer into the world of tiny science. We have a preview. One of the Imperial researchers who'll be at the November Late event is Dr Mitesh Patel of the Physics Department. He'll be talking about the small things that are detected by the very big thing, the Large Hadron Collider at CERN. Fundamental particles are the things you turn to if you want to understand how the universe works. Mitesh works on the LHC experiment, and it yielded some intriguing results last year. Hayley Dunning has been catching up with Mitesh and also finding out more about his work on that collider of little things, the LHC.
So the Large Hadron Collider is colloquially referred to as an atom smasher. So in fact, it collides protons, bunches of them. It smashes them together, and we try and understand what comes out. So we study particles that are produced, how they're produced, to try and understand what's really happening at the deepest level. So what matter consists of, what forces there are in the universe.
Probably the most famous result from the LHC that people have heard of is the discovery of the Higgs boson. But what else goes on there?
Beyond the Higgs studies, there's a lot that goes on. We are looking for new particles, new forces, phenomena that one can't explain with our current understanding of fundamental physics. So we study particles that come out of all different types in lots of different combinations to try and see if there are, for example, additional force-carrying particles. We also study the properties of particles we do know about to see if they behave in the way that our current understanding of the science says they should. So, for example, one of the things that I work on is how particles called B mesons disintegrate, and whether that disintegration happens according to our current understanding of particle physics, which we call the standard model.
I always find that interesting that physicists almost seem to want to break their own theories. So why are we looking for things that don't fit the standard model?
Our field's a bit unusual in its current circumstances, I think, because we really have a very, very quantitatively descriptive, powerful model of the science. So, the standard model was invented in the 1960s, and it's withstood pretty much every experimental test it's been exposed to ever since. You predict some quantity, you go measure that quantity in these huge experiments, and you can get those things to agree to 8, 9, 10 decimal places. So it's clear to you that it's telling you something about nature. And what's unusual about our field is that there's this incredible paradox that we know from, for example, the motion of galaxies, that the standard model doesn't provide a complete description of the mass or the energy that's out there in the universe. So we know from experimental observations that there's some dark matter, and there's no candidate for dark matter in the standard model. So if you look at the mass energy budget of the universe and ask what fraction of it can the standard model tell you about, we think the answer is about 5%, which for a fantastically quantitative model isn't great. We're really keen to break this model because it will open the door to understanding the vast majority of the stuff in the universe that we currently don't know about.
Now, talking about your own research, I know you talked about B quarks, which are beauty quarks. You've perhaps found some hints that the model may not be correct?
Yeah, we had in 2021 a really exciting and interesting result. The standard model predicts that the different kinds of a particular particle we call leptons, so the lepton that everybody has heard of is the electron, those particles have heavier cousins. The first of those cousins is called the muon, and then there's an even heavier version called the tau. And the standard model tells you that if particles fall apart to these different particles, the rate of the electron process and the muon process should be the same, barring any differences that you get from the mass itself, which you can compute very precisely. So one can get really accurate ideas of the ratios between decay rates. And what we were observing was that those rates were not in the ratio that the standard model predicted. And if that's true, it would be the first instance of an electron behaving differently to a muon at the most fundamental level. And there's no force in the standard model that could explain that. The reason there was a lot of excitement about this work was that it could be a hint, and it's yet to be confirmed, but it could be a hint that there are additional forces of nature that are not currently known in our description of fundamental particles.
So the LHC has just been upgraded and has restarted. So what will this allow us to do that it couldn't before? Could it help confirm your new result?
The LHC is going to be running for us at a much higher rate in our experiment than it has been able to do in the past. So we're going to have about 5 times the intensity of collisions. And so we can then collect the interesting events that we want to study 5 times more quickly than we could previously. At the other experiments, there'll also be higher intensity collisions, and that will allow us, for example, to study things like the properties of the Higgs that we talked about before with much more detail than we've been able to do up until now. So how does the Higgs disintegrate, and therefore do its properties tie up with our current thinking as embodied by the standard model?
Mitesh Patel talking there to Hayley. You can hear more from him and the other stars from Imperial at the Lates event on November the 10th. Well, now, let's take the second instalment of Andrew Youngson's mini-series, Feeling Like a Scientist. Do medics consider themselves to be scientists? I mean, they do wear white coats, but surely that's not where the similarity ends. One of Imperial's medical students has been grappling with all that, as Andrew has been finding out. And it's great to have you back, Andrew. So tell us a bit more about what you found out.
As mentioned on the previous episode of the podcast where we introduced this series, we'll be featuring over the next few episodes some audio highlights from the series that I've created. This time, as you say, we're shifting focus to the medicine side of things, and we're going to be hearing from student Tani Akinmoladun.
So what can you tell us about Tani?
So it was a really, really good interview. She's early in her time as a student, an Imperial Medic student, and just full of fresh insight, and it was really great talking to her. So she, first of all, told me a bit about her education background with science. So at secondary school, Tani really grew to love the sciences, especially biology and chemistry, she says. They both really caught her imagination, and thankfully for us, they led her in the direction to study medicine here at Imperial. But really interesting, and what led into the rest of the conversation was that as for feeling like a scientist, that's something that's only really happened for her very recently. So anyway, enough from me. Here she is talking about it in her own words.
I mean, it's only until recently that I even found out that, medicine and doctors, that falls under being a scientist. For me, like when you even say the word scientist, all I can think of is, a group of people in their lab coats, goggles, mixing up different potions and stuff. So definitely, majority of the time, I don't think I even felt like a scientist, just because of what we associate with the word scientist, just seeing on TV and stuff like that. So yeah, it's only until recently when I found out that, doctors actually fall under being called scientists that I'd say I can identify, since I'm learning science, right?
All right, well, Tani's obviously reflecting now quite a lot on what she has in common as a medic with being a scientist, and she seems to be considering herself more and more as a scientist, Andrew.
Yeah, absolutely. So she now sees herself as someone who learns science. She's studying at the moment, but she's also seeing herself as somebody who's able to apply it, albeit in a clinical setting, which is just a different form of science that she's come to realize. So really, the sky's the limit for her, the way that she feels. But even though she is wearing the titles of medic and scientist with pride, she was actually really quick to add that it's okay to take time to find your path. Deciding to study medicine, for example, came quite late for her. Here she is again.
I think it was even in year 12 that I decided, I'm just going to go for it. Before then, I can't say I knew exactly what I wanted to do. I can't even say that I knew I wanted to study medicine. And, even when I'd speak to people and they asked me in year 11, oh, Tani, what do you want to do? I was like, I don't know what I want to be in future. I know I'm going to do biology and chemistry for A-levels. That's just what I know right now. And it's okay. You don't need to know everything from the get-go. As you go along the years, you're learning a lot more. Me doing biology and chemistry in A-levels, I got access to, I learned about different career paths that I could do with that. So I just feel like no one should feel the pressure to know from the get-go what they want to do. Just take it slow and, just learn as you go.
So take it easy. I like that. Very important advice. And I'm sure that will be useful, for instance, for our younger listeners, taking something from that.
I think so too. I mean, in fact, this was a direction that we carried on in our interview. So I asked Tani what other advice she might have for young people thinking of a life in science, a career, an education path. And specifically, I actually asked her what she would tell her younger self if she was able to jump into a time machine. So here's the advice that she had.
First of all, just not to stress, because I definitely stressed out a lot when I was young about just knowing what I felt like I needed to know exactly what I wanted to do, and that wasn't the case. I feel like I would tell myself not to stress, just to take every day as it comes. And also, you can do anything that you set your mind to do. There's no magical whatever to determining what you can do. If you decide you want to be an engineer, you can do it. You just need to be focused and just go after it. So yeah, I definitely just tell myself, just encourage myself that I can do whatever I set my mind to do.
You get so much great advice and all these insights from these interviews. So yes, for those who want more on this, where should they go?
Absolutely. I mean, if people want more, there is more. There's 7 profiles in total in the series, Feeling Like a Scientist. It's all live now online on our Imperial Stories platform. This is what we call our home for the college's best storytelling. So the easiest way to find it is just put Imperial Stories into your favourite search engine and you'll find the whole series there. We really hope you enjoy it. And as we say, we'll be featuring highlights from it over the next few episodes.
Looking forward to it. As ever, it's been emotional, Andrew. Thank you so much. See you at the next one.
Thanks.
Well, finally, here's Hayley with Dr Richard Gill of the Faculty of Natural Sciences based at Silwood Park.
Now, you have been helping out a BBC film crew for a segment in Frozen Planet 2, the latest wildlife extravaganza narrated by Sir David Attenborough. But for a series about cold places, you've been advising about some rather surprising animals. Can you tell me about them?
Yeah, so we've been helping the BBC out with filming bumblebees of all organisms found right up in the Arctic. So we're particularly interested in bumblebees in Lapland, and we've been helping the BBC team in understanding how these organisms are able to cope with such extreme cold conditions in such a short window of time, because the season up in the Arctic is very short. My research has been understanding why these bumblebees have been responding to changes in climate and how they cope with such extreme conditions. For example, seeing them flying around above snow, trying to find the first flowers of spring.
Now, presumably, if they're adapted to those cold conditions, we might expect to see them having trouble under climate change. Is that the kind of thing you're seeing and researching?
Yeah, it's a complicated question, because the answer to that is sort of yes and no. The reason why we're interested is because there are some bumblebees there that are seen as Arctic specialists. So they've been in these very cold conditions for very long periods of time, and they are very well adapted to these cold conditions and being able to exploit the flowers that come out that are also very cold hardy. But there are other bumblebees that are now their range is starting to become more and more north. They're starting to creep into that environment and potentially compete with some of these Arctic specialists. So what we're trying to figure out is, are those Arctic specialists coping well or not so well with warming? And are these more lower latitude bees that are expanding their range and coming into this environment actually benefiting from that? And how is this complex community of bees responding?
Interesting. So that's your research, but tell me a bit more about working with the BBC crew. What did you show them? What did they want to know?
The BBC crew were very, very interested in trying to understand how these bees cope to such cold conditions. But they really wanted to get behind the story of how a single queen that hibernates over winter emerges, has to forage around over these very sort of snowy, very cold conditions, collect as much food as they can, so that's pollen and nectar from the flowers there, and then start her own colony. And it's really about the story of the commitment of this queen and what she's got to overcome when it comes to these cold conditions, because whilst it can be a few degrees above zero in the day and she's still flying around, at night it can plummet down to into minus conditions. So I was trying to help the BBC team out with taking them out into the field and finding these queens emerging, and also showing them the types of flowers that they're actually foraging on. So what I did is basically got this BBC team that had all of this video and camera gear to study and film these bees. And essentially every day we had to trek up a 1,000 metre mountain and find these bees, both foraging but also trying to get a glimpse of whether we see them coming out of their nesting holes or going inside them.
So where do you find these queen bees, and do they hibernate all winter? How does their life cycle work?
Yeah, it's actually very, very difficult to find them in the respect to where they're hibernating and where they're nesting. We think or believe, and certainly after this show there was some evidence to support this, is that the queens use old lemming holes. So in this environment we go to, you find lemmings, and these lemmings have these tunnels and burrows underneath the snow during the winter. If some of those tunnels come sort of dormant, bumblebees can actually take advantage of those, and they use them as both their hibernation nests, but also the nests that they will then use to start their colony, because bumblebees have colonies where they then rear workers and then new queens and males later in the season.
Why did you get involved, or why do you think it's important that we show these kinds of things?
So I think a lot of the fluffy animals, things like polar bears and your seals and other birds, they get a lot of the attention, and rightly so. They're in trouble, and we see the problems of melting ice caps with how polar bears are managing. But we've got to remember that they're just one part of the animal kingdom, and also life itself. Things like insects, such as bumblebees, are incredibly important. And they can also be incredibly important in these Arctic systems. So Just for example, bumblebees and other insects are very, very important pollinators of the flowers in these Arctic systems. And they maintain their health and make sure that they're good populations of those plants and flowers. And of course, the reindeer in those areas are very reliant on those plants and flowers. So there's a whole ecological network there. And insects are a major part of that. So if we don't understand how climate change and how these insects are living in this extreme world, then we really don't even understand how the whole ecosystem works. We've got to do that to even protect those more fluffy mammals and organisms.
Richard Gill speaking there to Hayley Dunning, and there's more audio related to that on the news pages of the Imperial website as two master's students from Richard Gill's group take the Field Notes on Climate Change podcast out and around to gather data on the bumblebees in the Arctic. It's amazing. And Frozen Planet 2 is now available on the BBC iPlayer. Just before I go, don't forget about our survey. You can find it on our podcast pages. Just go to Be Inspired on the Imperial website, and we're under social and multimedia. Well, I'm Gareth Mitchell, saying a very fond farewell from me and all of us here on the podcast team. Take care. Bye-bye.